Right. So at last, I have asked all of you to do the analysis. That is the calculation of the power in a three-phase same system for leading power factor load. So I hope all of you have done that. So now we will see, we will consider the previous case, whatever we have done for a lagging power factor load system. So let us discuss this, the variation in the wattmeter readings, right? Depending upon the power factor of the load. So we have seen that for lagging power factor load, the reading of the two wattmeters was W1 is equal to VL IL cos 30 degree minus phi, and W2 is equal to VL IL cos 30 degree plus phi. This we have obtained with the help of phasor diagram. It means that from here you can say that reading of the wattmeter not only depends upon the connected load, that is the load current, but also upon its power factor, because power factor angle phi is also included or mentioned in these in the reading of the two wattmeters, right? So let us consider the variation in the reading of the wattmeters depending upon the power factor of the load. So first case, let us consider when your power factor angle is equal to 0. So it means that it is a unity power factor load. You know the example of unity power factor loads in electrical system. These are basically resistive, purely resistive loads, right? So in this condition, you can see that when the phi is equal to 0, then W1 will be equal to W2 is equal to VL IL cos 30 degree. It means that both wattmeters indicate equal positive reading, right? So this type of reading is known as your scale reading, right? Now, second case, let us consider when your phi, that is power factor angle, is equal to 60 degree, which means that your power factor or cos phi will be equal to cos 60 degree, that is 0.5 lagging. So in this case, W2 will be equal to how much? W2 will be equal to VL IL cos 90 degree. VL IL cos 90 degree, which will be equal to 0. Not 0 degree, just 0, right? And in this condition, you can see that the power is measured by W1 only, right? So in this way, you can see the variation on the power measured with respect to the power factor angle. Now let us consider when phi is greater than 60 degree and less than 90 degree, right? It means that your power factor will be greater than 0.5 and less than 0, right? So in this condition, you can see that W1 will be positive, will have positive reading, right? But reading of W2 will be negative, right? यहाँ से देख सकते हो anything greater than 60 degree, the suppose greater than 60 degree and less than 90 degree. So in this condition, your W2 will give you the negative reading, right? That is, the reading of W2 is reversed as the phase angle between the current and voltage is more than 90 degree. Therefore, for getting the total power, reading of W2 in this condition, reading of W2 has to be subtracted from W1 in order to obtain the total power. So normally, what has to be done in this condition? You can say that for this range of the power factor angle, W2 will read down a scale, that is backward. So hence, to obtain a reading on W2, it is necessary to, in this condition, it becomes necessary to reverse either your connection of the pressure coil or the current coil. You know, in a wattmeter, there are two type of coils. First one is your, this is the symbol of a wattmeter. So this one is your current coil, and this is your pressure coil or voltage coil, right? So reading of the connection or the connection or polarity of either of the current coil or pressure coil has to be reversed in order to get the upscale reading of the wattmeter W2, right? Now, third or fourth case here is when your power factor angle is equal to 90 degree. That is, in this condition, you have a, that is pure inductive or capacitive load, as we are discussing here for lagging power factor load. So in this condition, it will be purely inductive load. Therefore, what will happen? W1 will be equal to VL IL cos 30 degree minus 90 degree, which will be equal to your VL IL sin 30 degree, and W2 will be equal to VL IL cos 30 degree plus 90 degree. So this will be equal to minus VL IL sin 30 degree. So you can see that if we add the two readings, that is the total power measured in the circuit in this condition will be equal to 0, right? So these are the different effect of power factor, load power factor on the reading of the wattmeter. So at last, if we make a summary table in this form, this is a summary table. So you can see that for different value of suppose power factor angle, the reading of the wattmeters, how it is varying. Suppose 0 degree, 60 degree, 90 degree. So this will be 1.5. This will be cos 90, that is 0. So W1 will be क्या क्या केस था? When your power factor angle was 0, then W1 and W2 was both positive and equal in magnitude, right? Positive. This was positive. For 60 degree, W1 was positive and W2 was negative, right? क्या था देखो इधर, पहले क्या देखे हम लोग, जब 60 डिग्री था तो W2 was 0, sorry. In this condition, your W2 is 0, right? And when your phi is equal to 90 degree, so reading of wattmeter 1 was positive and this was negative. ठीक है, इस कंडीशन में क्या था, W1 was equal to minus W2, right? Here W1 was equal to W2. So in this way, the load power factor affects the reading of the 2 wattmeters connected in a 3-phase system. So this is all about the measurement of power in a 3-phase system. Now, till now we have discussed about the measurement of power using 2 wattmeter methods, right? Now, there are some cases, special cases, like for example, you can see one case, a balanced 3-phase system, right? If the 3-phase system is balanced, मान लो कि ये एक 3-phase system है, this is connected in a star. Balance system का definition क्या है, that we have already हेलो हेलो आवाज आ रही
यस
है?
सर,
यस
आ रही
ओके
सर।
ओके
सर आ रही है आवाज।
हाँ, तो बैलेंस सिस्टम का डेफिनेशन जो है दैट वी हैव ऑलरेडी डिस्कस्ड दैट सिस्टम इज सेड टू बी बैलेंस्ड when the voltage and current in all the phases are equal in magnitude. Suppose we have a 3-phase system here. Suppose this is A, this is B, this is C. Then the magnitude of the voltage in each phase should be equal, as well as the magnitude of the current in each phase should be equal. Along with these two conditions, the voltage as well as the currents, that is suppose VA, VB and VC, these should be hello. Yes.
Yes sir.
There should be a phase difference of 120 degree between the phase EMFs or voltage, as well as this condition should also hold good for the currents IA, IB, IC. So there should be a phase difference of 120 degree between the any two adjacent phase or phase, right? So if these two conditions satisfied, then only we can say that our 3-phase system is balanced, right? Now if we talk about a balanced load, suppose there is a 3-phase load, this is source, right? It may be either alternator or any 3-phase generating source. Now if we talk about the passive component or passive element of the circuit, like suppose a load, a 3-phase load is there connected in a star, so the load is said to be balanced. The impedance, that is ZA, ZB, ZC should be equal. ठीक है, इसका मतलब बैलेंस तभी होगा when ZA is equal to ZB is equal to mod of ZC, right? अगर फेज एंगल कुछ है इसमें, सपोज phi A, phi B, phi C, obviously there will be some phase angle, तो वो भी इक्वल होना चाहिए. Only in that condition your load is said to be a balanced load. So here we are not talking about the balanced load, here we are talking about the balanced 3-phase system, basically about the source, right? उस 3-phase system में अब 3-phase load connect हो सकता है, that is secondary issue. So in this condition what will happen, If your system is balanced, then 1 wattmeter is also sufficient to measure the power in a 3 phase balance system. तो ये सपोज न्यूट्रल पॉइंट है स्टार कनेक्शन का तो इसमें करेंगे क्या हम लोग कि प्रेशर कॉइल का जो सेकेंड टर्मिनल है दैट विल कनेक्ट टू द न्यूट्रल एंड द करंट कॉइल विल बी कनेक्टेड in series with any of the phase. So suppose here we have considered phase A for the connection of the current coil. This is current coil, this is voltage coil or pressure coil. So you know that in a balanced system, the current will be equal in magnitude. This is IB. So the reading of the wattmeter will give you the total power in a single phase. That is phase A, right? So if you multiply the reading of this wattmeter by 3, then it will give you the total power consumed in a 3-phase circuit. But the condition is that your 3-phase should be, the system should be balanced in nature. ठीक है? अगर बैलेंस नहीं होगा तो क्या होगा IB का कुछ और वैल्यू होगा this will be this has the value which is different from IA IC will be also different from IA so in that condition we cannot just multiplying this by 3 factor we will not get the total power because the reading of the power in each phase will be different right but for a balanced 3-phase system using a single wattmeter method also you can measure the total power consumed in a 3-phase circuit राइट तो ये हो गया तुम्हारा पावर मेजरमेंट के बारे में राइट एनी क्वेश्चन नो क्वेश्चन ओके सो नाउ इसमें अब इस चैप्टर में यूनिट 3 में जो है सो सेकंड पार्ट इज योर measurement part which is basically in which you have to study about the constructional details as well as working principle of the different type of measuring instruments like voltmeter ammeter and wattmeter so that part we will leave now because that is not relevant that will be not relevant in case of the next chapters like magnetic circuits transformers or the machine part which we have to study so after completing the machine part that is the transformers DC machines induction motors at last we will discuss in detail about the different type of measuring instruments because that is not at all related to your the remaining part of the chapter right so in detail we will study about that part at last that is after the completion of the machine part so now today we will start your unit 4 of the syllabus unit 4 which is your magnetic circuits and transformers right so according to your syllabus we will only discuss about the single phase transformer ट्रांसफार्मर जो है वो सिंगल फेज भी हो सकता है 3 फेज भी हो सकता है राइट सो बट अकॉर्डिंग टू योर सिलेबस यू हैव टू स्टडी ओनली द सिंगल फेज ट्रांसफार्मर्स राइट वो काफी बड़ा एक खुद में एक बहुत बड़ा यूनिट है तो वो जो है सो अगर पूरा पढ़ने लगोगे तो पूरा सेमेस्टर चला जाएगा इसीलिए ये एक बेसिक सब्जेक्ट है इंट्रोडक्टरी सब्जेक्ट प्रिंसिपल्स ऑफ इलेक्ट्रिकल इंजीनियरिंग एंड मेजरमेंट्स दैट्स व्हाई ओनली द सिंगल फेज ट्रांसफार्मर यू हैव टू स्टडी I hope all of you have seen the syllabus which was circulated among you, right? So now this chapter has two parts. First, in the first part, that is the magnetic circuit part, we will see the basics of the magnetic circuits. And then after covering that, in this magnetic circuit part, we will also discuss about the different laws like Faraday's law of electromagnetic induction, then your right hand rule, then after that the Lenz law. So everything we will discuss. We will see the analogous property of a magnetic circuit to the electrical circuit. what are the different components of a magnetic circuit, what are the different terms used in a magnetic circuit. So we'll see all these things in this first part, and after completing this we will talk about or discuss about the constructional features as well as working principle of a single phase transformer, right? So let us now start the magnetic circuits or systems, right? So can anyone define the circuit? What is a circuit? We have already completed the first unit, that is your DC network theory, in which we have discussed about and we have solved several electrical circuits. You have also submitted one assignment related to that. सर्किट को कैसे डिफाइन करते हैं बताओ? Anyone? आवाज नहीं आ रही है क्या? हेलो?
Yes, sir.
अच्छा, आवाज आ रही है, बताना नहीं कोई चाह रहा है, चलो ठीक है. So circuit is basically a closed path which is formed by various elements through which the quantities, electrical quantities can be transformed, right? मतलब एक ऐसा closed path, अब closed path है तो closed path बनाने के लिए कुछ elements required होंगे. So what are the various elements of electrical circuit? So the various elements may be a voltage source, current source, then your passive elements like resistor, inductor, capacitor. So these are the different elements of electrical circuit, right? So if we have to define a circuit, electrical circuit, then this is a closed path which can be formed by various elements through which the different quantities can be transformed, right? Quantity means you can transfer the power through electrical circuit, you can transfer current or voltage through the electrical circuit, right, using various elements of the circuit. Now similarly, if we talk about magnetic circuit, so magnetic circuit is basically a closed path formed by magnetic materials, ठीक है? Closed path which can be formed by magnetic materials, right? Through which normally flux completes its path through the magnetic circuit, right? So closed path formed by the magnetic material through which magnetic flux can flow or complete its path. So basically flux is your analogous to current if we compare the magnetic circuit to an electrical circuit. So electrical circuit में क्या होता है, current जो है अपना path complete करता है through any closed loop or path, right? But in case of magnetic circuit, the analogous to current is your flux, right? So flux completes its path through the magnetic circuit, right? So you can take one example here. So you can take one example of a simple magnetic circuit, like suppose this is a rectangular magnetic circuit formed by some magnetic material. For the time being, you just understand that this is a core, right, which is made up of magnetic material, like it may be of any type, CRGOS, like cold rolled grain oriented steel sheets, which is mainly used for the construction of transformer cores. It may be also hot rolled steel type, anything, any magnetic material. So let us consider this is a cross sectional area of a core which is made up of your magnetic material. Now here on this path, suppose a winding has been done, right, with the help of a coil, right? So now if we excite this coil with the help of external voltage source, AC voltage source V, then a current will start flowing through this coil because it is a complete circuit. So as per the definition of the electrical circuit, current has to complete its path when the coil is excited. So what will happen? So when a current is flowing through any coil, then what will happen? Basic law है ये. Flux will be developed, right? तो flux develop होगा, and that flux will follow this path, that is the magnetic material path, right? ये बीच वाला part जो है, this is your air or any other medium, oil हो सकता है या कुछ भी हो सकता है, but this is a magnetic path, so the flux will follow the magnetic path. So it will complete its path through this core, right? So due to the electromagnetic property here, the flux will flow through the core or closed path. Due to the electromagnetic property, the flux has been generated, which is completing its path through the core, right, or the closed magnetic circuit path. So here in this chapter, we will only talk about the electromagnetic circuits. It means magnetic circuit is not your independent circuit, right? Electromagnetic circuits should be there, because electromagnetic means there are certain advantage of the electromagnets compared to the permanent magnet. You should know about the property of the permanent magnet, that you don't need any excitation. In case of permanent magnet, there is a permanent north and south pole. In the case of permanent magnet, so due to which the line of forces will be there, which is known as your flux, north से south pole की ओर जाता है. But the main disadvantage of the permanent magnet is that its magnetic property is constant. It cannot be altered or changed, either increased or decreased. By the time जैसे जैसे बीतेगा, इसका magnetic property deteriorate करेगा, decrease करेगा, but it is not going to increase. But in case of electromagnet, suppose if we consider a magnetic material on which we provide some coil like this, so if we want to make it a magnet, electromagnet, then we need to excite this coil with the help of any additional source. So suppose here we have considered a voltage source due to which a current will start flowing through this coil. So now, depending upon the magnitude of this current, the strength of the magnet can be increased or decreased. अगर I increase करेंगे, तो your lines of force will be more. Stronger magnet you can obtain with the help of electromagnet condition. So we will mainly talk about the electromagnetic circuits throughout this subject. Means जब तक हम लोग machine part discuss करेंगे, everywhere you will see the electromagnetic circuit, right? So you will see that in an electromagnetic circuit, the various things will be dependent upon the electrical quantities also. Therefore, in order to understand the concept of an electromagnetic circuit, uh, we will have to first of all discuss about the analogous property. Analogous property of magnetic circuit and electrical circuits, right? ये समझ में आ रहा है क्या हम लोग डिस्कस कर रहे हैं?
Yes, sir.
Yes, sir.
Right. So let us now consider or discuss the different elements or terms used in a magnetic circuit. First one is your magnetic flux, which is normally represented by 5, right? So what is flux? If we have to define the flux, then how it can be defined? So for that you will have to understand uh, or you will have to think about electromagnets. So let us consider we have a magnetic material on which we have a pole pair. Pole pair means combination of north pole and south pole, right? So there will be a line of force from the north pole towards the south pole. This is the property of any magnet. नॉर्थ से साउथ की ओर जाएगा, right? So flux can be defined as your amount of lines of forces originating originating from north pole towards the south pole. This is your definition of the flux, that is the amount of lines of force. ठीक है, तो normally this flux is represented, the unit is in Weber. So if we talk about the electrical circuit, then this magnetic flux is analogous to your current. ये हम लोग पहले भी बात कर चुके हैं, right? So flux, यहाँ से जो अभी हम लोग डिस्कस कर रहे थे, flux of 1 Weber is equivalent to 10 to the power 8 lines of forces. ठीक है, next term used in a magnetic circuit is your magnetic flux density. Magnetic flux density, which is represented by B, capital B. Now density का मतलब क्या होता है? Density of anything cannot be defined without knowing the area of that magnetic material or anything. For example, you can consider one case. Normally हम लोग क्या कहते हैं कि यूपी जो है बहुत पॉपुलेशन जो है यहाँ बहुत डेंस है, और इन इंडिया इटसेल्फ द पॉपुलेशन जो है काफी ज्यादा है, पॉपुलेशन डेंस है यहाँ पे. इसका मतलब क्या होता है कि जितना एरिया है उसके रिस्पेक्ट में जो है सो आदमी बहुत ज्यादा है. तो सिमिलरली in case of defining the flux, magnetic flux density also, it is defined as the flux transferred per unit area, right? So this is flux per unit area. So this unit of the magnetic flux density is basically in Weber per meter square. So now can you say the term which is analogous to this magnetic flux density in an electrical circuit? Electrical circuit का कौन सा ऐसा term है जो इस magnetic flux density के analogous है? Flux के analogous कौन सा है? हाँ बताओ.
Current density.
Right, current density. So you know that current density in an electrical circuit is basically your current per unit, current transferred per unit area, that is I by A. So flux is analogous to current, right? So current density is analogous to your magnetic flux in a magnetic circuit, right? Now third term, let us discuss about the magnetic flux intensity. Magnetic flux intensity, normally expressed by capital H. So how much intense is the magnetic field? This is your magnetic field intensity, right? And that is, you can define it in this way. How much intense is the magnetic field, right? तो अब जैसे कि इसको ऐसे समझ सकते हो कि अगेन कंसीडर द सेम मैग्नेटिक मटेरियल व्हिच वी हैव डिस्कस्ड प्रीवियसली व्हाइल defining the flux. So there was north south pole, right? Now if you want to measure the intensity of a magnetic field, so what you will have to do, first of all draw the line of forces. So let us put a magnetic material inside the north pole, right? This is a magnetic material. So how much force this magnetic material will receive when placed near the or the adjacent to the north pole, right? So this will give you the information about the intensity of a magnetic field. So H is equal to your Ni by L, से दिया जाता है, where N is your number of turns of conductor winding, ठीक है. I is your so you can say the supply current, and L is your length of the conductor, right, in meter. तो ये हो गया magnetic field intensity. So if we write the unit of this magnetic field intensity, then this will be simply for this
Sir, you're not audible.
hello network, hello.
Yes, sir. अब आवाज आ रही है
Yes,
सर.
you're audible.
Okay. So next one is your permeability. Which is denoted by mu. So this permeability basically holds the same identity as permittivity do in the electrical circuits, right? So you know about the permittivity. Permittivity is your basically epsilon is equal to epsilon naught epsilon r. So here in magnetic circuit you have permeability which is represented by mu, so which is equal to mu naught mu r, right? So here mu naught is your absolute permeability, which is equal to 4 pi into 10 to the power minus 7, right? And mu r is your relative permeability. So this mu r is basically one for air and vacuum. The other values of mu r will be depending upon the medium used, right? So I just want to recall all these things, the various terms used in the magnetic circuit, so that from the next class onwards we can discuss the things in detail. So now the fifth one is your reluctance. So reluctance is basically analogous to the resistance used in the electrical circuit. Resistance के analogous है. तो can anybody define resistance? What is resistance in any electrical circuit?
Sir, obstruction in the flow of current.
Right. Resistance is basically property of any electrical circuit which opposes the flow of current, right? जैसा कि तुमने कहा obstruction electric current के flow में. So similarly in magnetic circuit, reluctance is a property of a magnetic circuit which opposes the flow of magnetic flux, right? That is the opposition offered to the flow of magnetic flux is your reluctance. So the expression of reluctance is L by mu A, or in detail you can write L by mu naught mu r A. So if you write the unit of this one, then this is ampere turn per Weber. So this is the definition as well as the expression of reluctance in a magnetic circuit. So now
सर ये मैग्नेटिक फ्लक्स इंटेंसिटी इसका क्या है एनालॉगस इलेक्ट्रिकल सर्किट्स में?
हेलो
सर जैसे मैग्नेटिक सर्किट में आपने बताया कि मैग्नेटिक फ्लक्स इंटेंसिटी होता है, तो इसका एनालॉगस क्या होगा सर? इलेक्ट्रिक फ्लक्स मतलब इंटेंसिटी फिर?
जैसे देखो यहाँ इसके बारे में 3 के बारे में पूछ रहे हो
ये
क्या?
सर इनका एनालॉगस क्या होगा सर?
ये इलेक्ट्रिक फील्ड स्ट्रेंथ होता है ना,
यस सर
जैसे कि that is equivalent to electric field strength only, right? हेलो
यस सर, ठीक है सर.
हाँ. So now if we compare if we do the comparison of magnetic and electric circuits, ये हम लोगों ने अभी देख लिया है ईच कंपोनेंट के बारे में, लेकिन फिर भी एक समरी टाइप से अगर देखें, सपोज इफ दिस इज इलेक्ट्रिकल circuit column, this is magnetic circuit column, then in case of electrical circuit you know that Ohm's law से जो है लीनियर सर्किट्स को हम लोग डिफाइन करते हैं, जिससे क्या बोलते हैं, current flowing through a circuit is directly proportional to the voltage, provided that the resistance of the circuit is constant. Means at constant temperature the current flowing through the circuit should be directly proportional to the voltage. This is your Ohm's law. Now in case of magnetic circuit, your Hopkinson's law should be valid, according to which flux is equal to mmf by reluctance, right? कहीं कहीं mmf को जो है सो कैपिटल F के थ्रू भी रिप्रेजेंट करते हैं, right? Now here resistance is there. In case of electrical circuit, which is basically R is equal to rho L by A. ठीक है. Now in case of magnetic circuit, you have reluctance. Reluctance is just we have discussed L by mu A. Here you have current flowing through the circuit. Here you have flux flowing through the magnetic circuit or magnetic material. Here you have suppose if voltage is there as an EMF source, वोल्टेज की वजह से जो है सो करंट फ्लो करता है सर्किट में. वोल्टेज मींस ईएमएफ की वजह से करंट फ्लो करता है. सो देयर शुड बी एमएमएफ शुड बी देयर इन ऑर्डर टू फ्लो द फ्लक्स through the magnetic circuit. So mmf का equivalent emf है electrical circuit में and vice versa. Here you have, in case of electrical circuit, you have conductivity. Right, here you have permeability. Right, तो ये सब जो है so different analogous components हैं. So I hope all of you understood the basic concepts used in or basic terms used in a magnetic circuit and how it is related to the electrical quantities. So from next class onwards, we will discuss about the properties of a magnetic circuit and the different laws associated with a magnetic circuit, and then how it is applicable in case of single phase transformers. Right. Thank you. Any question? बताओ भाई, कोई क्वेश्चन है किसी का?
नो सर.
ओके, कल क्लास नहीं होगा. कल पता होगा तुम लोग.
यस सर,
में कुछ
नोटिस
फाइल
आया.
आया तुम लोगों के पास? कल सारा क्लास
यस सर. आज